Can you all hear me?
Yes, sir. Your voice is audible.
Okay, so we will wait for a few minutes more. Let some other students join. Then we will start at 7:10 around.
Okay, no problem.
Hello everyone. So you can see my screen. I have shared a presentation currently.
Yes, sir. It's visible.
Okay, so now let's start our discussion. So once again, I welcome you all to this interaction session, which is based on the course uploaded by NPTEL this January 2024 session. This is Atomic and Molecular Physics. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. I will be taking the session weekly at 7 p.m. to 9 p.m. every Friday. So starting from today, we will start our discussions, and in each session, I will solve a few questions which will be based on the lectures of this week. Like if I am doing in the interaction session 1, there will be questions that will be based on the lectures of week 1 of the course content, which will definitely help you to solve the assignments which are being plotted in the course this year. So let's start our discussion. So the first question is, among the following, which model was unable to explain the stability of an atom? The options are Bohr's model, Rutherford's model, Thomson's model, and the option D is none of the above. So can anyone tell me what will be the correct answer? Which one of these model was unable to explain the stability of the atom? Yes, anyone? Can anyone tell me?
Sir, Rutherford's model.
Yes, the correct answer will be Rutherford's model, because if we talk about different models of the atom that was given by different scientists, so the first and the most basic model was Thomson's atomic model. And according to Thomson's atomic model, if we talk about Thomson's atomic model, basically Thomson's atomic model is otherwise called as plum pudding model, because according to Thomson, he said that an atom is nothing but a sphere of positively charged particles, or a positively charged sphere, and in which the negatively charged particles like electrons are embedded. Like if this is an atom, so the whole sphere is made of a positive charge. So if we cut an atom, like there will be an intersect, so here there are some negative charges like this, which are being distributed uniformly in the atom. So basically this model is called as plum pudding model. So here plum refers to electrons, that is negatively charged particles. These are the plums, and the overall positive charge distributed throughout the atom is called as pudding. So this is pudding, and it refers to positively charged protons. So there was nothing about the neutrons and any other thing. So this was one of the basic model. Then if we come about the next model that was proposed by Rutherford's model, and according to Rutherford's model, it was given that the you must have known the famous experiment which Rutherford has carried out. That was Rutherford's gold foil experiment, in which Rutherford tried to scatter the alpha particles by a gold foil. So from his experiment, he was able to give a number of postulates about the shape and about the distribution of atomic particles in an atom, which is called a Rutherford's atomic model. And according to Rutherford's atomic model, what he said, in case of Rutherford's gold foil experiment, he discovered a positive charge center, because in gold foil alpha particle scattering experiment, most of the alpha particle had passed through the gold foil undeflectedly. So if you see, so most of the, according to Rutherford, he said that most of the space in an atom is empty, but some of that alpha particles were scattered head on were scattered exactly in opposite direction and some scattered with some angles. So since alpha particle has positive charge and it is being scattered, so it gives an evidence that the charge particle which is present is also positive. So we can say that most of the mass and the whole positive charge of an atom is concentrated at the center of the atom, which is called as nucleus. And nucleus, we know nucleus consists of protons and neutrons, and electrons are and according to Rutherford, electrons are revolving around some circular orbits. If this is an atom, then all the positive charges are concentrated at the center, and then the electrons are revolving around the nucleus in circular energy levels, which are called as orbits. So if we talk about if you talk from the point of view of the stability of the atom, we know according to Maxwell theory, if uh, a charge particle is being accelerated, then definitely it will emit radiation. And if the electron which is being revolved around this, when the electron which is revolving around this nucleus at certain energy levels, so it will emit radiations, and due to which its energy will decrease, and as well as the path, that is the distance or the radius of the orbit will again goes on decreasing, and after a certain amount of time it will collide with that nucleus. So atom will be destroyed, because there will be, so since positive charge and negative charge will attract each other. So if you consider Rutherford's atomic model from the point of view of stability, then it was unable to explain the stability of an atom, because the theory which was given by Rutherford was violating the Maxwell's principle. And if you talk about Bohr's atomic model, Bohr's atomic model is one of the most advanced atomic model, because after that there was minor corrections like Sommerfeld atomic model, which is again based on the postulates that was given by Bohr. So starting from Bohr's model, there was inclusion of quantum mechanics, and in the proceedings in the upcoming weeks we will discuss in details about Bohr's model. So the correct answer in this question will be Rutherford's model, because according to Rutherford's model, electrons are revolving around the nucleus. But if you talk about the stability, then Rutherford's model was not able to explain the stability of the nucleus. And also there is another limitation of Rutherford's atomic model. Rutherford only told that the electrons are revolving around the nucleus in different energy levels, but how those electrons are arranged, because if you consider about different elements have different number of electrons, so it is not possible that all electrons are revolving in a single energy level. So Rutherford's model was again unable to explain the distribution of electrons in an atom. So the correct answer for this question will be B, which is Rutherford's model. So then, is there any doubt regarding this question? Anyone? Okay, so let's continue our discussion. Now the second question is, J.J. Thomson's cathode ray tube experiment discovers of the options are nucleus, protons, neutrons, and electrons. So can anyone tell during the experiment performed by J.J. Thomson, which is very famous experiment known as cathode ray experiment, he discovered a particle, and it was whether it was a nucleus, protons, neutrons, or electrons.
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 Yes, so electrons. So you can clearly see cathode ray means, so cathode is positively charged or negatively charged. So this is cathode and this is anode. So cathode is positively charged or negatively charged electrode. Can anyone tell?
Positive charge.
No, cathode is negatively charged electrons. Anode is positive. So, sorry, cathode is negative and anode is positive. You can remember it such a way that you know there are cations, anions we say in chemistry. So cations are positively charged ions and anions are negatively charged ions. So cations are attracted towards cathode and anions are attracted towards anode. So if you see there is a, so in this figure you can see that is a cathode ray tube. Basically this is a tube which is known as cathode ray tube. It consists of a heater, and this heater there is a filament here. So this filament acts as the source of electrons, and then when the heater is heated, then it will emit electrons, and these electrons, since these are anodes are positive, so electrons, since the cathode is negatively biased and the anodes are positive, so electrons are again negatively charged particles, so they will be attracted towards anode, and as a result they will be getting focused. Because if you see, suppose these are the two electrodes and they are being accelerated. Suppose there are two sets of electrodes. This one is plus 20 volt and this one is plus 100 volt. So if you see, if the electron is coming here, then it will be attracted towards plus 24 volt, because here it is negative or 0 volt, we can say. So it will be attracted towards the positive volt electrode, and since there is a gap, so electron will flow within this gap. And then again, if you see the difference between these two sets of electrodes are, suppose one is plus 100 volt, another plus 20 volt, so the electron will be again attracted. So as a result, the electron will be getting focused. And also there are deflecting coils. Deflecting coils means, now these coils like focusing coils and accelerating coils was mainly we are using mainly for horizontal motion. And if you want to deflect, like if you want to move the electron in y direction, that is vertical direction, then we can use the deflecting coils. So if the biasing is, suppose this is negative and this is positive, so if an electron is coming, then it will be attracted towards the positive electrode. As a result, it will be deflected in the plus y direction. And similarly, if we give positive here and negative here, then the electron will be attracted this towards this region and it will be in negative y direction. And after that, it will again get again it will reach at a screen which is fluorescent in nature, and it will produce light radiation. And this cathode ray tube experiment is so if you see the rays which are coming from the cathode are beam of electron. So the cathode ray tube experiment was able to discover the particle electrons. And if we does anyone know where the cathode ray tubes are used?
Televisions.
Yes, nowadays there are the televisions are based on LEDs and other things, but if you talk about 10 years or 20 years back, then there were televisions which was, if you if you are interested, then you can see, if you have some older televisions, then you can, if you open it, then you can see there is a tube like this. And also in case of if you are doing any lab experiments, you must have heard of cathode ray oscilloscope. So there is an oscilloscope which is used to see the waveforms of the any voltage signals or current signals. And in that, the cathode ray tube also, cathode ray oscilloscope, these cathode ray tubes are used. So then the third question, the principal quantum number, which is also known as n, this number describes, the option is radius of the orbit, the option B is shape of the orbit, the option C is spin of the electron, and option D is size of the nucleus. So we know there are different quantum numbers. So if you talk about principal quantum numbers, so we know the principal quantum number for a state, then or for a orbit, then what we can make out of this quantum number, whether we can using this quantum number, whether we can determine the radius of that orbit, or we can determine the shape of the orbit, or spin of the electron, and size of the nucleus. So what will be the correct answer in this question?
Shape of the orbit,
Size.
sir.
Okay.
Sorry, once again.
Shape of the orbit.
So no, I think if you see
Size
quantum
of
number,
the.
no, if you see there are different models of atom. So in which model first the quantum numbers were introduced? Can anyone tell me? Because
Bohr
if you
model,
consider
sir.
Bohr model, so in case of Bohr model, if you talk about Bohr model, then according to Bohr, all the orbits were circular orbits. So there was no description about the shape of the orbit in case of Bohr's atomic model. In I think in week 2 only we will be discussing about the atomic models in details, like in Bohr, what are the expressions of radius of the orbit, what are the expressions of energy. So we will discuss. So can you then tell me what are the quantum numbers we know?
Principal quantum number.
Principal,
Magnetic.
azimuthal, magnetic,
Yes,
and
so we
orbital.
have first one is principal quantum number. Principal quantum number, which is denoted by n.
Yeah.
Here, and then the second one is azimuthal quantum number, which is given by L. Which is given by L. Then the third one is orbital quantum number, ml, and the fourth one is spin quantum number, ms. So these are 4 quantum numbers. But if you talk about principal quantum number, then in case of Bohr's atomic model, there was only the principal quantum number was used, or principal quantum number was explained only. So if you talk about principal quantum number, then principal quantum number explains the radius of the orbit, because in case of Bohr's atomic model, the shape of the orbit was not discussed, and spin of the electron is related to the spin quantum number, and the size of nucleus is not relevant in this case, because here we are talking about the atoms. So the correct option here will be radius of the orbit. But how we can say that it explains the radius of the orbit? Because if we see in case of Bohr, he gave different derivations, like if an electron is revolving in an energy level, then what will be the radius of that orbit, what will be the velocity of the electron in that orbit, what will be the energy of the electron in that orbit. So here if you see, r is the radius, d is the velocity, and e is the energy. All these 3 parameters are related to the principal quantum number, because they depend upon n. So if you talk about if you talk about radius of the orbit, then the formula or the expression is n square h square epsilon 0 by pi m z square. And if you talk about velocity of the orbit, then it was z square by 2 epsilon 0 n and h, and energy is minus 1 by 8 n square h square epsilon 0 square by it is m z fourth. 1 minute. So it is m z square e fourth by n square h square epsilon 0 square. So this is the expression of energy. So if you see all these quantities, like energy of the electron in an orbit, velocity of the electron in an orbit, and radius of that orbit, all depends upon the quantum number n. So here, but no energy and velocity options are given, so only option is radius of the orbit. So the correct option here will be radius of the orbit, and the spin of the orbit is explained by spin quantum number. The shape of the orbit is explained by basically azimuthal quantum number, and the size of nucleus, where since we are talking about the atoms, then we can determine the size of the nucleus from principal quantum numbers. So the correct answer here will be option A, which is radius of the orbit. Then question 4, which of the following quantities is always a whole number? The options are atomic radius, atomic number, atomic weight and equivalent weight. So can anyone tell me whether out of these four quantities, which quantity is always a whole number? There are no
Atomic.
fractional numbers.
Atomic number.
Atomic numbers.
Okay, so we know
Number.
atomic radius. Atomic radius, like if you can anyone tell me what is the radius of the ground state energy level of hydrogen atom? We will basically anyway we'll be discussing it in upcoming weeks. But can anyone tell me if anyone knows from Bohr model for hydrogen atom what is the radius of ground state? So it is known as Bohr's orbit, which is 0.53 angstrom. So this is the atomic radius or radius of that orbit. And atomic number, you know, atomic number is given in terms of Z, and Z is the number of, what is Z? Yes, can anyone tell me what is Z? Atomic number Z equals to
Number of protons.
number of protons inside the nucleus of that atom. So Z equal to number of protons. And we know protons are if you currently we can still decompose, or we can still uh, so protons and neutrons, we are saying before a few years we knew that protons and neutrons are subatomic particles and they can be broken into smaller particles. But currently if you know about quarks and gluons, then quarks protons and neutrons are made up of quarks. So but in case of these models, we consider atomic number Z, and atomic number Z is equal to the number of protons, and it is a whole number always. So we can't say some atom has 1.2 number of protons or 1.4 number of protons. So always each atom has whole number of protons. Or and in case of atomic weight is nothing but the weight of the. So can anyone tell me what will be the atomic what is the formula for atomic weight of hydrogen? How we write hydrogen? We write hydrogen as 1H1. 1H1 means 1 is here. This one is Z, that is atomic number. And this one is A, which is mass number. And this mass number is equal to Z plus N, where N is the number of neutrons in the nucleus. So if you talk about the mass of hydrogen atom, then it will be mass of proton, because in case of in the nucleus of hydrogen there is only a single proton, hydrogen has no neutron. So it will be mass of proton plus mass of electron. We know mass of proton is how much? Can anyone tell me mass of proton is in kg?
1.67 into 10 minus 23 kgs.
No, it's not minus 23. It is minus
27.
27 kg plus electrons
9.1 into 10 minus 31.
31 kg. So if you add it, so as it was correctly said by Rutherford, most of the mass of an atom is concentrated at the nucleus, because if you compare the mass of proton and mass of electron, the electron is 1 by 1800, roughly 1840 times smaller. Electron has 1 by 1840 times smaller mass than that of the proton. So if you see mass of proton plus mass of electron is nearly equal to mass of proton. So most of the mass of an atom is concentrated in the nucleus. So if you see here, these are not whole numbers. So atomic weight can be whole numbers, atomic radius can be whole numbers. So can you tell me what is equivalent weight?
atomic weight or valency?
Atomic weight, equivalent weight is atomic weight divided by valency. So what is the weight of nitrogen atom? What is the weight of nitrogen? What is the mass number of nitrogen?
28.
What is the atomic?
At 14 and 28.
No. 28 will be the
Mass.
molecular weight of nitrogen. If you talk about atomic weight, it consists of only a single nitrogen. So it is. If you take, it will be 14. So and the what is the valency of nitrogen? It is 3. So if you see here, if you divide 14 by 3, then it will not be an whole. It will not be a whole number. So equivalent weight is again not a whole number always, because if you see for oxygen is 16. For oxygen is 16 and its valence is 2, so it is 8. It is a whole number, but in case of since it is a ratio, so the valence, if the valence is not even, then it will not be a whole number. So in this question, out of these 4 quantities, only atomic number is always a whole number, and all other numbers are not whole numbers always. Then the 5th question: an atom of an element has 1 electron in the outermost M cell. Its atomic number is, option A is 1, B is 10, C is 11, and option D is 17. So can anyone tell me what will be the answer?
Eleven.
Yes. Any other?
11.
So the correct answer here will be 11. So if you see, there are principal quantum numbers which is known as n. And what are the values of n? Yes, anyone? What are the values of n?
Two n plus 1.
No. What are the values of n?
One from one.
1 to some n.
Exactly. N can't be 0, because if you see, if in the previous question we are solving here, radius is n square s square epsilon 0 pi m z square. If you put here n equal to 0, then radius will be 0. So it will be wrong definitely, because electron can't be present inside the nucleus. So the value of n starts from 1, 2, 3, 4, 5, like that. And according to the value of n, we have named the orbits. So name of the orbits. So name of the orbit, for n equal to 1, what is the name of the orbit?
K.
It's K. For n equal to 2, the name of the orbit is L, M, N, like that. So if and again the electrons are, according to Bohr, the electrons are distributed in different orbits according to their principal quantum number. So suppose the orbit X and the quantum number for this orbit is n, then what is the maximum number of electrons that can be placed in the orbit? What will be the maximum number of electrons?
2n square.
It is 2n square. So if you see, in case of K, it will be 2 into 1 square, which will be 2. Then in L, it will be 2 into 2 square, which is 2 into 4 equals to 8. Then to 2 into 3 square, 18, and then 32.
36.
So If you see here in the question, it is given an atom of an element has one electron in the outermost M cell. So if you talk about the number of cells, suppose this is the nucleus and these are the energy levels. So in my drawing, these are not exactly circular, but actually the energy levels are circular according to Rutherford. So if you see here, this is K, this is L, this is M, and this is N. So according to the distributions of electrons, then in K cell there will be 2 electrons. So there are 2 electrons in the K cell, and in L cell there are 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So since the element has 1 electron in the outermost M cell, then all these cells are filled. So the element has K cell, its K cell is filled and its L cell is also filled. So the total number of electrons present in K and L is 8 plus 2, which is 10. Then if you come to M cell, it has only a single electron, and so the total number of electrons for that element will be 10 plus 1, because here it has only one electron, so it will be 10 plus 1. So the total number of electrons will be 11 for that element. So can you tell me, while drawing this distribution of electrons, why I have placed the 2 electrons at a single place?
According to Pauli's exclusion principles.
So basically this is in relation with the spin of the electron. So as we discuss about different quantum numbers, then we will come to know about in this is KLMN. Then these orbits are again divided into a number of orbitals. Then these orbitals are divided into number of cells, subcells. So in that case, there will be spin of the electrons, there will be orbital spin of the electrons, there will be there will be other magnetic moments of the electrons. Then we will talk about that there are spins of the electrons, and 2 electrons having different spins or opposite spins are present in a single cell. So I have drawn here 2 electrons. And regarding Pauli's exclusion principle, can you tell me what Pauli's exclusion principle tells? Yes. So according to Pauli's exclusion principle, yes.
No two electrons have the same 4 quantum numbers.
Exactly. So if in an atom there are a number of electrons, any 2 electrons can't have all the 4 quantum numbers equal. So if you talk about a single electron, if you talk about a number of electrons, their n may be equal, L may be equal, Ml may be equal, but this value will not be equal, because according to spin of the electron, suppose the electron spin is half, then one will be plus half, another will be minus half. So if you draw the energy level diagrams, like if you draw the subcells, so plus half is up spin and minus half is down spin. So like this. So here one electron has ms plus half, another electron has ms minus half. So no 2 electrons in an atom can have all the 4 quantum numbers equal. So the correct answer here will be 11, because its K cell and L cell has been filled, which is 2 plus 8 equal to 10, and the extra one electron present, which is present in the M cell, is added to 10. 10 plus 1 is 11. So the correct option is 11. Now the next question. The question says, find the wrong statement relating to Dalton's atomic theory. The statements are, option A is every substance is made up of extremely small particles known as atoms. Option B is atoms are not the ultimate matter particles and can be subdivided into smaller particles. Option C is atoms can't be created or be destroyed during a physical or chemical change. Different different elements atom have different chemical properties. So these are the 4 statements given here. And according to if you talk about Dalton's atomic theory, not any other theory, only Dalton's atomic theory, then one of the 4 statements is wrong. So which one is wrong here?
Option B.
So if you anyone, which one is wrong here?
Option
B.
B.
Yes, so here the wrong option is option B, which says atoms are not the ultimate matter particles and can be subdivided into smaller particles. Now if you see, we know atoms are not the ultimate matter particles because inside atom we have electrons, protons and neutrons. But during the time period of Dalton's, when Dalton gave the theory of atom, then according to his theory, if you see the postulates of Dalton's atomic theory, he said that elements consists of invisible small particles which are called as atoms, and these atoms can be created and nor be destroyed. So since we can't destroy an atom, so atoms are the ultimate matter particles and they can't be divided. But here option B is saying atoms are not the ultimate matter particles and they can be subdivided. So according to Dalton's atomic theory, this option is wrong because Dalton said that atoms can be divided. So here also the remaining 3 are these 3 postulates of Dalton's atomic theory. Different elements, the atoms of different elements have different chemical properties. Every substance is made up of small particles which is known as atoms, and atoms can neither be created nor be destroyed during a physical or chemical change. So out of these 4 options, option B is wrong because it says that atoms are not the ultimate particle, that is atoms are not the smallest entity of the substance and they can be further divided into smaller particles. So then let's come to the question number 7. Now the question number 7 says an electric field E acts between a pair of parallel plates as shown in figure. The length of each plate is L. A charge Q enters in space between plates with initial velocity V, which is perpendicular to the field direction. Find the vertical displacement of the charge inside the plate. And what we have to consider? We have to consider that there is sufficient space inside the plate for the vertical displacement. That means it is not that within the distance L, because if you see the question says there is an electric field E which acts between a pair of parallel plates as shown in figure. So these are 2 pair of parallel plates. One is positively charged, another is negatively charged. And if you see these lines, yellow lines, arrow mark, the lines are being directed from positive to negative charge, and we always know that these are called as electric field lines, and electric field lines are always directed away from positive charge and directed towards the negative charge, because electric field lines are nothing but the movement of a unit positive test charge. Like if you see here, if you keep a positive charge here, it will move towards the negative charge and it will move in a straight line. So here the lines of force are plotted. Here the lines of force are given and the length of each plate is L. So from here to here the length is L. A charge Q enters in space between the plates with initial velocity V. So the charge is entering from this side. This charge Q enters with a velocity V which is perpendicular to the field direction. The velocity V is only perpendicular direction, that is if this is the direction of the field, then the velocity will be perpendicular to it. Then we have to find the vertical displacement of the charge inside the plate. So if the charge particle is moving from here to here, that is when the charge particle moves a distance L in horizontal direction, then what will be the displacement of the charge particle in vertical direction? Then we have to consider that there is sufficient space, because so why we have to consider there is sufficient space? Because if there is not sufficient space between the 2 charge particles before traveling this distance L, it is possible that the charge particle might get absorbed in any of the one plates, because it will again depend upon the charge of the particle. If this particle has charge positive, then it will be attracted towards negative and it will absorb here in the negative plate. And if it is and if the charge of the particle is negative, then it will be absorbed in the positive plate. But here we have to consider that the charge particle won't be absorbed as the space between the two plates is sufficient. So if we see here, suppose the distance between these two plates is d, maybe suppose the distance is d, then here it will be d by 2 and here it will be again d by 2. So at any moment of time, the displacement, vertical displacement in this direction is always less than d by 2, because it has sufficient space. So the charge particle will definite will definite pass through the two plates and it will be coming out of the two parallel plate combination. So we need to calculate here the vertical displacement of the charge particle inside that plate. So I'll give you a few minutes to solve this question, and after that I will try to discuss it. I try to explain you how the calculations will be made. Yes, anyone? Can
Answer
anyone tell me
B, sir.
what will be the answer?
Answer B.
Okay, so any other student who has solved it? The answer B is correct. Now, can any other student was able to solve it? So now let's discuss this problem. Now the question says an electric field E acts between a pair of parallel plates as shown in figure. So if you see this figure, the direction of the electric field is in, suppose if this is the coordinates, this is x and this is y, then the direction of the electric field is in minus y direction. So we know if a charged particle q travels in a electric field E, then what will be the force experienced by that charged particle?
Q into E.
Q into E. So Q into E. So if you consider about the vectors, then F vector will be Q vector into E vector. So if Q is positive, sorry. So if Q is positive, then the direction of F vector will be equal to the direction of E vector. And if Q is negative, then the direction of F vector will be negative that of the E vector. That is, the direction of F vector and E vector will be anti-parallel. So here we are not going to consider any charge because here it is only given the charge Q. But if you talk about the polarity or the positive or negative, so if an electron comes, suppose this is the electric field. This is the electric field. So an electron will experience a force which will be opposite to that of electric field. So if this is the force on electron, then it will be in the negative direction of the electric field. But if a proton or positive charge particle travels in this field, then it will be in the same direction as that of the electric field. Because if you see, electric field lines goes from positive to negative charge. So electrons will be attracted from negative towards positive, and the protons will be attracted from positive towards negative. So here, if you see the if you see the trajectory of the charge particle given in these blue lines, so it is being attracted towards the positive plate. So can anyone tell me what is the charge of the charge particle, whether it is negative or positive?
Negative.
Yes. So here, if the motion is given, then this type of motion will only be experienced by a negatively charged particle, because negative charged particle will experience force in opposite direction of that electric field. So now let's come to our discussion. Then here the force will be Q E. Now, since here there are no vector involvement, so we will only do scalar treatment of this. Then we know force is mass into acceleration. So ma equals to QE, or A equals to QE by M. So here you see the acceleration is QE by M. And if you talk about the direction of acceleration, which direction it will be accelerated? It will be along the direction of this E, because again A vector will be QE vector. So since the electric field is along minus Y direction, the acceleration will be along minus Y direction, or any or plus Y direction, depending upon the amount of charge or the nature of charge. But very simply we can say that the acceleration is QE by M. Now, if we talk about the horizontal motion, here it is given the charge particle q enters the space between the two plates with its velocity v perpendicular to the field direction. So the field direction is minus y. So the direction of the velocity is along this x direction. So the motion is, so the initial velocity v, this vx or velocity of the particle along x direction is v, but the velocity of the particle along y direction is 0. That is the initial velocity 0. Only the component of the velocity is along perpendicular direction of the field. So the perpendicular direction of the field means x direction, and the initial y direction is the initial velocity along x direction is v, but the initial velocity along y direction is 0. But here in the question we need to calculate the vertical displacement. Vertical displacement means displacement along y direction. So we need to calculate y. And if you talk about the, let me add another slide. So if we talk about the if you talk about the equation of motion, we know S is ut plus half a t square. So all calculations will be of the vertical direction, because here we want to calculate the vertical distance y. So if you talk about the parameters in the right hand side, it is u, that is initial velocity, a is acceleration, and t is the time period. So what will be the time period in this case? If the velocity is v and the here it is given, consider that there is sufficient space inside the plate for vertical displacement. So suppose that here what is the time t? Time t is the amount of time taken by the charge particle to traverse this distance L. So if the velocity of the particle is v and the distance of the horizontal distance is L, that is the length of the plates, then what is the time? The time period t will be L by V, that is length of the plates and divided by the velocity of the plate. So, and again if you see u is initial velocity, and the since all the velocity was along the horizontal direction, so the vertical direction velocity is 0 and acceleration is all, and the if you see only acceleration here, it is along the vertical direction, that is y direction. So here ay is q e by m. So y will be 0 into t plus half into QE by m into t square. We know t is equal to L by b. So L by b square. So vertical displacement y will be half into L square divided by v square into QE by m. Or if we write, it will be L square QE divided by 2m v square. So this will be the correct answer. So if you see, the option B is correct. QEL square divided by 2mv square. So is there any issues with this problem, or everyone understood it? Yes, anyone?
Yes, sir, it's understood. No problem.
Okay, so here only the question is about the vertical displacement. So if you see the equation of motion, we need all the vertical direction values. So along the vertical direction, we want to calculate the displacement. So the time period is L by V. Initial velocity is 0 because the initial velocity V was along horizontal direction only. And the acceleration is along the electric field, which is in vertical direction. So the acceleration is QE by m. If we put all the values in this equation, the displacement will be L square QE divided by 2m v square. Now the next question. The question says, in previous problem, what is the vertical component of the velocity at the moment the charges leaves the plate? So here, let me draw it again here. 1 minute. What we can do, I can just, no. So this is the situation. This is positive. This is negative. The lines of force are like this. Particle Q is moving with velocity v. This distance is L. Any other information given? No. V. So this is the case. Here the question says, what is the vertical component of velocity at the moment the charges leaves the plate? Yes, so can anyone tell me what will be the vertical component of the velocity, because initial component of the velocity is 0. In the previous question we said initial component of the velocity is v. We calculated the acceleration is q by m, but we did not calculate any velocity. So in the next question, the question is what will be the vertical component of the velocity at the moment the charge leaves the plate?
It will be C.
Option C, sir.
So what will be the value? It will be QEL divided by MV. So can anyone tell me what will be the velocity? Now let's solve this one. Then I will go to the next question which I was talking. So if you see in previous question, the acceleration was QE by M. So AY is QE by M. Now velocity is acceleration into time. So time is L by V. So why here L by V is why we are using L by V, not any other values? Because here it is given the vertical component of the velocity at the moment the charge leaves the plate. The charge leaves the plate means the charge has traveled distance L and it is leaving just after L. We need to find out the vertical velocity. So it has traversed the distance L completely. So here it is L by V. So if you see, it is QE by M. From previous questions we calculated it is QE by M. Then it is L by V, which will be Vy. Vy at L will be how much? It will be QEL divided by MV. So the correct option here is option C. So can anyone tell me what will be the velocity when it is at the mid of this plate, two plates, like here? If the particle is here, then what will be the velocity of that particle in vertical direction?
QEL by 2 MV.
Yes, exactly. So here the time will not be L by V, it will be L by 2 divided by V. So it will be L by 2V. So here the time is L by V because it has left the region, that is it has traversed the whole distance L. But if the distance traversed is only L by 2, then the velocity will be QEL divided by 2MV, because the distance here will be replaced L, we will replace L by 2. So the correct option here is option C, QEL divided by MV. So is there any issues with this problem? So always remember we need to consider the direction. If we consider the horizontal direction or vertical direction, here since the now here see if the in this question the force is being applied along one direction and the particle is moving along other direction, due to which the velocity is increasing in the direction in which the force has been applied. So the particle will bend in a direction which is perpendicular to the initial direction, because the force on the particle is in a direction perpendicular to the initial motion. As the particle goes through the region, then it will be experiencing more and more force or more and more so it will change its direction more and more in the vertical direction. Then question 9. According to Faraday's first law of electrolysis, the amount of any substance deposited at the electrode is directly proportional to the quantity of option A is voltage drop across electrolyte, option B is resistance of electrolyte, option C is electric charge passed through electrolyte, and option D is electric current passed through the electrolyte. So can anyone tell me, according to the Faraday's first law of electrolysis, what will be the amount of any substance deposited at the electrode and which is directly proportional to the quantity, and what is the quantity? Option A is voltage drop, option B is resistance, option C is electric charge, and option D is electric current passed through the electrolytes.
Option C.
Electric charge. Option C.
Electric charge.
Yes, so correct option is option C, electric charge. So now let's discuss about the laws of electrolysis. Faraday's first law of electrolysis says. So according to Faraday's first law of electrolysis, the mass of the substance which is deposited at any electrode is directly proportional to the amount of charge passed. So if you write the formula, if you write the statement in mathematical ways, then the mass will be directly proportional to the charge passed. And if you introduce a proportionality constant, the proportionality constant is called as Z, and this Z is called as electrochemical equivalent. And this electrochemical equivalent is the amount. If you see here, M equals to ZQ. So if you put here Q equals to 1, if put here Q equals to 1, then M will be Z. So Z is the mass of the substance which is deposited at electrodes during electrolysis by passing 1 coulomb of charge. So if you put here Q equal to 1, that is 1 coulomb of charge is passed, then the amount of substance that is deposited at the electrode is known as electrochemical equivalent. Then talking about the second law of electrolysis, the second law of electrolysis states that the mass of a substance deposited at any electrode on passing a certain amount of charge is directly proportional to its chemical equivalent weight. Like here, if you see in the previous question, there was a option which was equivalent weight. So here, this is the equivalent weight, chemical equivalent weight, or when the same quantity of electricity is passed through several electrolytes, the mass of the substance deposited are proportional to their respective chemical equivalent weight. So here the mass of the substance is directly proportional to the amount of charge passed, but here the mass of the substance deposited is directly proportional to the chemical equivalent of that weight if the other parameters are constant. So here W is the mass of the substance and E is the chemical equivalent weight of that particular substance. And if you consider two substances, the ratio will be W1 by W2 equal to E1 by E2, where E is known as equivalent weight, and the equivalent weight, what is the formula of equivalent weight? Equivalent weight is atomic weight divided by valency. So now, suppose if you talk about, let's talk about this second law in a more detailed manner. So I request everyone to mute themselves. So now let's talk about the second law in a more detailed manner. Do we know what is the charge of electron?
1.6 into 10 to the minus 19 coulomb.
1.6 into 10 to the power minus 19 coulomb. And what is so if you talk about mole, then 1 mole is equals to how many number of particles? Avogadro number of particles.
Yes.
And what is this value? Na 6.03 into 10 to the power minus 10 to the power plus 23. So if you see, if we consider the charge of 1 mole of electrons, then 1 mole of charge of 1 mole of electron, the charge will be 1.6 into 10 to the power minus 19 into 6.023 into 10 to the power 23, which is equals to 96,500 roughly, and this value is known as 1 farad. So 1 Faraday, not farad, 1 Faraday. 1 Faraday is the charge of 1 mole of electrons. So if we pass 1 Faraday of charge, then 1 gram of the equivalent weight will be deposited. So if you write the if we write the equation, then it will be W equals to Q divided by 96,500 into E. So if we put here Q equal to 1 Faraday, then this will be cancelled out. E will be equivalent to W. That is, if we pass 1 Faraday of charge, then 1 gram of equivalent weight will be getting deposited. So this is another formula. And if we compare the two formulas, like here we said that W equals to Q divided by 96,500 into E, and in the first formula it is M equals to ZQ. It is W equals to ZQ, or here W is nothing but M. So W or M equal to ZQ. So if you compare these two equations, then we can say that Z equals to E divided by 96,500. So the electrochemical equivalent is equals to chemical equivalent weight divided by 96,500. So now let's come to our question. Now the question says, according to Faraday's first law of electrolysis, the amount of any substance deposited at the electrode is directly proportional to the quantity. So it is directly, we have discussed, it is proportional to the quantity of electric charge that is passed through the electrolyte. So the correct option is option C. So now let's come to the question 10. Now the question says, electrochemical equivalent may be defined as the dash of the substance deposited in the electrode when 1 coulomb of charge passed through the electrolyte.
Mass.
So it
Mass.
is the postulates of first law of electrolysis. So it is M is direct proportional to Q, and M equals to Z into Q. So if you pass 1 coulomb of charge, so Q equals to 1 coulomb, then M will be Z. So we know Z is electrochemical equivalent. So the electrochemical equivalent is defined as the mass of the substance that is deposited in the electrode when 1 coulomb of charge is passed through the electrolyte. So the correct option here will be option B. Then question 11. The question says, the same quantity of electricity is passed through different electrolytic cells connected in series, containing different electrolytic solutions or in molten stage. Let M1 and M2 are the masses deposited and E1 and E2 are their equivalent weights respectively. Then the options are M1 and M2 equals to E1 divided by E2, M1 M2 equal to E1 E2, M2 divided by M1 equal to E1 divided by E2, and option D is all of the above. So the question says, the same quantity of electricity is passed through different electrolytic cells and they are connected in series. So we know in series the current remains constant, but in case of parallel the voltage remains constant. So same amount of charge. So here same quantity of electricity is passing means same amount of charge is passing through the different electrolytes because they are connected in series. Then let M1 and M2.
ఈ ప్లేస్ బాగుందిరా, ఎందుకంటే ఇక్కడ కూర్చుంటే నా వైఫై డ్రైవర్స్ పోవట్లేదు, నాకు నిద్ర కూడా
Oh no. So I again request everyone to mute themselves.
దిగుతా చదువుకుంటారా అట్లీస్ట్ నేను.
Now then if no one I request everyone to mute themselves. Otherwise, I will be forced to mute all participants. So I can't interact with you. So here, here is given same quantity of electricity is passed through different electrolytic cells and they are connected in series containing different electrolytic solutions in molten state. Mass M1 and M2 are the masses deposited and E1 and E2 are the equivalent weights respectively. Then which of the equations will be correct? Option A is M1 by M2 equals to E1 by E2. Option B is M1 M2 equals to E1 E2. Option C is M2 by M1 is E1 by E2. And option C is all of the above are wrong.
Option A.
So the correct option will be option A, which is M1 by M2 equal to E1 by E2, because if you talk about the second law of electrolysis given by Faraday, it says W is direct proportional to E. So W is nothing but mass of the substance. So M will be direct proportional to E. So M1 will be direct proportional to E1 and M2 will be direct proportional to E2. And if you consider the proportionality constant, which is here in this case, the proportionality constant is Q by 96,500. So if you take the ratios of the two substances, that is M1 divided by M2, M1 divided by M2, then it will be E1 divided by E2. So the correct option here will be option A, which is M1 divided by M2 equals to E1 divided by E2. Now let's come to the next question. The question says electrolysis of dilute aqueous NaCl solution was carried out by passing 2 ampere current. The time required to liberate 0.01 mole of hydrogen gas at the cathode is. So how much the time will be required to liberate 0.01 mole of hydrogen gas at the cathode? Now we have to take F equals to 96,500 coulomb and the equivalent weight of hydrogen is 1 gram. So I will giving a few minutes to try this question and solve it. Then after a few minutes we will discuss. Yes, can anyone tell me what will be the time required to liberate 0.01 mole of hydrogen gas at the cathode if we are passing 2 ampere of current in aqueous NaCl solution? Yes, anyone? Yes. Is there anyone who has solved it? So here the question says we are passing 2 ampere of current. So here current I is 2 ampere. The time required. So we need to find out the time to liberate 0.01 mole of H2 gas. So 1 mole of H2 gas is how many grams? Hello, am I audible to you?
Yes.
So can you tell me what is the mass of 1 mole of H2 molecule?
2 gram.
2 grams exactly. So the mass of 1 mole of H2 molecule is 2 gram. Then what will be the mass of 0.01 mole of H2 molecule? It will be 0.01 into 2 gram. That is
0.02
0.02
gram.
gram. So this is the amount of H2 gas deposited at the one deposited due to electrolysis when we are passing 2 ampere of current, and we know current is
Q equal to IT.
so I is equal to Q by T or Q equals to IT. Now in the expression, mathematical expression for first law of electrolysis, we know mass equals to Z into Q. Z into Q is I into T. So now if you see here, T will be M divided by Z into I. So now what will be the value of Z here? Here it is given, it is equivalent weight, but Z is electrochemical equivalent. So if you see the discussion, then the relation between Z and ER, Z equals to E divided by 96,500. So in place of Z, we can put E divided by 96,500. So it will be M divided by E divided by 96,500 into I, or T equals to M into 96,500 divided by I into E. We know all these values. What is the value of E? This is nothing but E. E is 0.02 gram, is not it? Sorry, no, it is not E. It is sorry, 1 minute. So here it is given the equivalent weight of hydrogen is 1 gram. So E is 1 gram. Then mass deposited is 0.02 gram. I is 2 ampere. So M will be 0.02. If we are writing units, then 0.02 gram into it is 96,500. It is nothing but coulomb. Then I is 2 ampere into E is 1 gram. So gram and gram will be cancelled out. Then if you calculate coulomb divided by ampere, it will be in seconds. So the overall unit of this quantity will be second, because the time here it is t. So the answer will be 0.02 into 96,500 divided by 2. So it will be how much? Please calculate and tell me. You see here the options are in some minutes and some seconds. So please calculate and tell me these are how many seconds and convert it to minutes.
965 seconds.
So then it will be in terms of minutes.
16 minutes, 5 seconds.
Minutes. 16 minutes.
16 minutes and 5 seconds, not 16 minutes. So the correct option will be 16 minutes and 5 seconds.
5 seconds.
So everyone understood how these type of problems you should solve? Because here we know the expressions contains only charge, amount of charge we are passing, but here there is current. So current means some amount of charge passing to some interval of time. So we need to calculate that interval of time. So in the expression for mass of the substance deposited, we will put the values in terms of current, and then since we know the equivalent weight of the hydrogen, and if we put F equal to 96,500 coulomb, so we will calculate. Here it is how much you are saying, 965 seconds, which is nothing but 16 minute 5 second. So this is the correct answer. So we'll solve one more question today. So let me add some slides. We have some time, so now we will solve a similar question that we solved in the class, like for example this question. So in this question there were no values, only the notations. So let's try this type of another question with the values. So the question says, now let me just write down the values. But the question says, this is question number 13. An electron moves with a speed of 4 into 10 to the power 7 meter per second along positive x direction. An electron is moving along plus x direction, and the velocity of direction is 4 into 10 to the power 7 meter per second. And in the direction where there is a uniform electric field of strength 5000 volt per meter, which is directed along positive y-axis. Now there is a electric field whose strength is 5000 volt per meter, and the direction is along positive y-axis. The length of the field is 2 meter. Like in the question there was length L. Now here the length L is 2 meter. And the question says determine the deflection of the electron when it just comes out of the field. Like we need to calculate here. Determine the deflection. Determine the deflection when it just comes out of the field region. And in this case we need different values. We need charge of the electron. The charge of the electron is 1.6 into 10 to the power minus 19 coulomb, which is negative, and the mass of electron is 9.1 into 10 to the power minus 31 kg. So let me draw an illustration. So here the field is along plus y direction. So this is the direction of the field. which is plus y direction, and the electron is moving along plus x direction. The electron is moving in this direction, which is plus x direction. So this is the length of the field. The length of the field is 2 meter. So can anyone tell me what will be the deflection? Deflection is nothing but the vertical displacement. So we need here we need to calculate y. Suppose this is x direction and y here is 0. Suppose here y equals to 0. Then can anyone tell me if this is an electron, then electron will be deflected in which direction? Plus y direction or minus y direction?
Plus y.
Excuse me, once again.
Plus y direction.
No, how plus y direction? I just
Minus
told
y.
you na the force of the electron, the force equals to q e vector. Since it's an electron, its charge is negative. No, it's okay. But so if it is a vector, it will be minus e vector into e. So if the direction is along, if the electric field direction along plus y direction, the force on the electron will be along minus y direction. So if you draw the path of the electron, it will be somewhat like this. So here we need to calculate this distance when it comes just outside the field, and the length of the field is 2 meter. So if you have understood the previous problems, then you can easily solve it. So try to solve it and tell me what will be the displacement or deflection of the electron, and use these values. Charge of the electron is minus 1.6 into 10 to the power minus 19 coulomb, and the mass of electron is 9.1 10 to the power minus 31 kg.
1.09 meters.
I'm getting around 0.8.
Once again. So the correct answer will be 10 by 9 meter, like it will be 1.1 approximately. So
Yes, sir, 1.09 meters.
yes, so the direction, again the direction will be along minus y direction, and the deflection is 1 point, it is approximately 1.1 meter, or you can simply write, it depends upon the option. If the options are given, we can accordingly, we can, since here I am not giving you any option, I just need the approximate values. So how will we solve it? So can anyone tell me how will we approach this problem? The problem is same, but here the values are given. So if you see, A is equals to ut plus half at square. So y will be uyt plus half ay t square. Here uy is 0 because there was no initial vertical direction of velocity. There is no initial vertical direction of motion, only the velocity was along horizontal direction. So what will be the time to overcome the length 2m, because here it is given the length of the field is 2 meter. So the time will be L divided by V. So L is 2 meter and the velocity is 4 into 10 to the power 7 meter per second. 4 into 10 to the power 7 meter per second. So this is the amount of time it will take. Then if you put here, y will be half into ay. Ay is nothing, we know. A is QE by m. Here Q is charge of electron, m is mass of electron, and E is 5000 volt per meter. So since all units are in SI standard, so we will put directly, it is 1.6 into 10 to the power minus 19 into E is 5000 divided by the mass of electron suppose take it 9 or 9.1, whatever you can take it, into 10 to the power minus 31. So if you solve it, again here t square is 2 divided by 4 into 10 to the power 7 whole square. So it will come around 10 by 9 meter. So the answer is 10 by 9 meter. So if now you see, if it is crossing 2 meter, then the distance will be 1.09 or 1.09 meter. So after crossing distance 2 meter, the vertical distance it traveled is 1.09 meter. Now this same question can again be, so if you see, this same question can again be written. Suppose this is the length. Now the question may come, at what distance the electron will strike the screen. Suppose this is negative and this is positive, the electron is moving in this direction. So at what distance, if the here it will be giving, suppose the distance between the two plates is 10 meter. So the electron is moving in this direction. So the electron need to strike here. So what will be the length? Suppose this is x equal to 0, then what will be x here, so that the electron strikes here. So here, what is the displacement along y direction? It is 5 meter. So you need to calculate the length it will travel, so that it can experience a deflection of 5 meter. So first you will calculate the time, because here here everything is, everything you need only to calculate the time. So if you put y equal to here 5 meter, then you can easily calculate time, and once you calculate time, you know the velocity, then you can calculate the length or the region through which it will travel, so that it can experience a deflection of 5 meter. That is, it will collide with the screen, because the distance between the two screen is 10 meter. So I think we will stop it today. So is there any doubt in this question or any other question that we have solved today?
No.
In next week we will discuss some other problems which will be based on the week 2 lectures of your course. I hope these types of questions will be helpful for you in your solving in your assignments, as well as when you will be appearing for the exams. So it will definitely be helpful. If you have any other doubts, you can also ask me. Okay, so thank you all for joining today. In the next Friday, we will discuss some new problems which will be based on the week 2 lectures. I again thank you all. That's it from my side.
Thank you, sir. Thank you.
Thank you,
Okay.
sir.
Welcome.
Thank you, sir.